Okay. Mi si sente?
Our next speaker is Daniela Dalbagno, and we spoke a little bit with last question. We'll be talking about the flow time in learning.
Okay, can you hear me? Okay, fantastic. So I'm Daniela Dalbagno, I'm a PhD student here at the University of Bologna, and the work I'm presenting regards the role of the motor system during the expectation of the threat, and in particular, how the motor system can learn the timing of the threat. So we know that when we build the knowledge of the threat, we take in account not only spatial information, but also temporal information of the threat, to know when and where the threat could occur in the environment, to be able to perform the best action in response of the threat. And this is in accordance with the imminence of the threat theory, for which we can change our behavior in relation of the position and the temporal aspects of the threat. So the temporal processing is an aspect in fear conditioning, and we also know that the motor system is involved in time processing. So, for example, it seems to be involved in particular in the internal clock component, that is a measure that allows to take account of the passage of the time during an event, for example. Okay. Starting from the study showed by Sonia, we decided to investigate whether the motor system learns not only the spatial characteristics of the US, but also the temporal characteristics of the US. So we know that the motor cortices present a modulation with a side congruent way, so considering the position of the shock. But we don't know about the temporal characteristics of the US. So the question is, does the motor system learn the temporal characteristic of the threat of a threatening stimulus during the threat conditioning? So during the learning of a threat value of the stimulus. And to so the aim of the study that I'm presenting is to investigate whether this inhibitory pattern we found 60 milliseconds before the presentation of the threat is maintained inhibition, so from the presentation of the stimulus that predict the threat, or whether this inhibition is focal, so is presented only when the threat should occur in the environment. And to test this aim, we used 3 initially neutral stimuli as in the previous experiment, so 3 colored dots. And we recorded maps as a measure of the corticospinal excitability during the task, during the presentation of the stimuli into timings, okay, during the presentation of the stimuli. So we had 3 CS. The first was a CS plus early. So a conditioned stimulus associated with a shock delivered early, so 1.75 seconds after the onset of the stimulus. And we had also a CS plus late, so an initially neutral stimulus associated with a shock after 5.5 seconds after the presentation on the screen. Okay, so the difference, the stimuli were presented for 7 seconds on the screen, and the difference between the CS plus early and the CS plus late was in the presentation of the shock. So we had a shock early associated with the CS plus early, and a shock late associated with the CS plus late. But all the stimuli lasted for 7 seconds on the screen. Okay, oops. And then finally, we had a CS minus, so a control stimulus never paired with the shock during the task. TMS was applied during the presentation of the stimulus, and we had a delivery of the TMS 60 milliseconds before the delivery of the shock early for the CS plus early, 60 milliseconds before the delivery of the shock late for the CS late, CS plus late, but also TMS delivery during the expectation of the threat. Okay. And we applied TMS in the different position that we found to counterbalance the TMS delivery among the three CS, but also to investigate whether the modulation of the motor cortices change before and after the presentation of the shock in this case. Okay, so this is the paradigm. And we had two main hypotheses. The first one is a phasic hypothesis, for which the inhibition that we found in the previous experiment is focal for the timing in which the threat should occur, okay, in which the shock should occur. So in a schematic way, we can see that the inhibition is focal for, is early for the CS, when we presented the CS plus early. So when the shock should occur, and for the CS plus late in this phasic hypothesis, we can expect an inhibition only when the shock late should occur. Okay, so in this case, the inhibition is focal for the timing of the threat delivery. But we also had a sustained hypothesis. For this hypothesis, the inhibition that we found is maintained during all the expectation period of the threat. So it's not focal, but in a schematic way, as you can see in the CS late, after the stimulus onset, the inhibition is maintained during all the presentation until the shock should occur in the task, in the environment. Okay. To test those two hypotheses, we performed a task similar to the experiment that we performed before. So we recorded map from the FDI muscle on the right hand of participants, and we delivered shock on the right arm of participants, and TMS was delivered on left M1 of participants. All the data and results are recorded from a sample of 18 participants, but right-handed participants, but those are preliminary data and results because we have to reach a sample of 28 participants, so work are in progress, but we have some data. Going to the results, we have results for the explicit responses by participants, and as you can see, the variance is lower for the CS plus early and the CS plus late compared to the CS minus, and the shock expectancy is higher, and also the contingency declared for the CS plus early and late compared to the CS minus that was never paired with the shock. So these results can say that the conditioning was successful. Okay, but going to the results for the motor cortices, those are the results. Okay, this is the experimental design, and those are the results. So you can see in yellow the CS minus map amplitude, and as you can see, the amplitude is higher in the CS when the CS minus was presented as compared to the CS plus early and the CS plus late. So we can confirm that the presentation of a CS plus can produce an inhibition compared to the CS minus in general. But we had two main hypotheses. So to test the hypothesis, so whether the phasic or the sustained hypothesis is the better way to describe our data, we use Bayesian informative hypothesis. Okay. And we perform two contrasts. The first one is the contrast between the CS, between the three CS. So we compared at the first TMS delivery time point the inhibition of the motor cortices, and whether the phasic hypothesis is true, we can expect an inhibition at the first TMS delivery time point for the CS plus early, but not for the CS plus late and the CS minus. While whether the sustained hypothesis is true, we can expect a similar inhibition for the CS plus early and the CS plus late, but not for the CS minus. Okay. And the contrast on our data showed that the sustained hypothesis, there is a mistake, the H2, the sustained hypothesis has the highest probability to describe our data, okay? So for the first contrast showed that the inhibition is maintained from the presentation of the CS on the screen until the presentation of the shock on the participant's arm. But we also performed a second contrast within the CS plus late to compare the inhibition at the first TMS delivery time point with the second TMS delivery time point. And whether the phasic hypothesis is true, we can expect an inhibition only when the threat should occur. So in the second TMS delivery time point, but not in the first. While whether the sustained hypothesis is true, we can expect a similar inhibition between the two time points, okay? And also in this case, on our data, the contrast, also in this case, there is a mistake. The contrast showed that the sustained hypothesis has the highest probability to describe our data. Okay. So going to the conclusions, in this exploratory study, we confirmed that in presence of a stimulus that predicts the arrival of a shock of a threat, participants showed an inhibition of the motor cortices. And this inhibition follows a sustained hypothesis. So after the presentation of the stimulus in the environment, the inhibition is maintained until the presentation of the threat. So participants learn the threat, learn the timing of the threat, and they modulate their motor cortices according the time on which the threat should occur in the environment. Thank you. Questions, suggestions? Something, anything? No? Okay.
No, thank you for answering the previous question.
Yeah.
So, very, very nice and elegant experiment, and I look forward to seeing it. No, well, I was just curious to know whether you would expect any, if this inhibition be prolonged in a situation in which the stimulus is more variable. Imagine, of course, it's an empirical question, but let's say that you would expect two shocks instead of one, and be delivered random. Would you? So, what's your personal idea? Would you expect to be the inhibition to be maintained until you are safe, or?
Okay.
I mean,
okay.
If it's
Okay. The results show that so this is the CS plus early in blue. Okay. So we found that the inhibition is presented when the shock should occur, but there is an increase of the map amplitude when we consider the second TMS time point delivery. So we can expect that when I'm safe, I reduce my inhibition maybe. Okay. But we have to collect more data, so I don't know the real response.
It makes sense. You want to still protect yourself, and also in the although maybe the physical alert, the temporal features, still I mean, it seems that it is a sort of protective
But
response.
but some participants didn't learn the temporal association of the shock, and I saw yes, one explicitly, one both, and one not, so only implicitly. And I found that map amplitude was similar to each condition. So maybe they didn't know that they were safe, so the map amplitude was not modulated in time. Okay, so maybe it's only when you know that you are safe, you can reduce your inhibition.
So when you answer the question, didn't present the data.
Yeah.
To replicate this rate,
Yeah, we also had.
Oh, right.
Mhm.
Yeah.
Mhm. Yeah, thank you.
Well, thank you, Chef. It's,
I was inhibiting today.
Not anymore.
Not non sufficiente.
How did you also get it? You use the score?
Those are data score, Z scores. Those are that scores. Yeah.
Okay, so thank you again, Daniela.
Thank you.
Avevi la camicia